Okay.
The first one, okay, so in this format that you have done it,
Mm-hmm.
was it possible, like in the place where you put the lamp, like with the terminal screw
The screw terminal
point?
block.
Yes, could you have used a lamp there?
If only I have a lamp that can sit on PCB. Okay, so in case the lamp I want to use, it is something that can be mounted on a PCB, then I could design a library for it and use it, yes. But in this case, we are looking at a lamp that can sit on a PCB. That means the only way we can connect it is to connect it to the connector. Do you understand?
Ah, yeah, I understand.
So because the
So
lamp can directly, the lamp and the battery, both of them cannot sit directly on the PCB. That's why we are using connectors as a way to attach them.
okay.
Yes.
Then I'm coming now. So where the power input is, the DC barrel,
Mm-hmm.
um, um, could you then have used the screw terminal and then used like the battery symbol, such that like
Exactly.
if you mount the screw terminal, then you would use the battery symbol that you used in the
Ex-
second drawing. You
exactly.
could have used
So you are looking at
okay.
something like this. It's a connector. So yes, I could have just done it like this if it's the screw terminal that I wanted to use. I could have done it like this. Okay. The fact is,
And then you
mm-hmm,
needed a battery, or you wouldn't have added a battery
added the battery
to the power input uh, segment,
here. So the
like
battery,
so
as
before
in,
the lamp. Ah.
so the battery flag is still there, right?
Okay, I was thinking, like, you see that other battery symbol that you use, would you like have put it before that screw terminal?
Is it this
Would it
one?
have no, no. So okay, so like the power input section, that this side. So let's say before the lamp,
Before the
like
lamp.
on the left side. Sorry, I'm sorry. Okay, so I was actually reading this ahead, this particular one that you've written. So
So this,
I
if
mean,
I
let's
do
say,
this, this is now supposed to be battery, like the battery's port, where we will connect the battery.
and that's how you would have done it. Like
Exactly.
that's how
So
it
this
could
will be
be done.
like power in. Previously we called it what? Power in, right? So this will now become our power in. If it's the screw terminal that we want to use.
Ah, okay, okay.
Yes.
Initially, like I was thinking, you see that battery sign that you selected on the second image that you said, like that one is not like people who are experienced who design that. You see that battery symbol. So I was
Ah,
thinking that
oh, okay.
that battery symbol before this
Oh,
terminal
okay.
screw,
I get you.
before
So you
is
know
that
there are
possible?
batteries that you can mount directly on PCB. Okay. Uh,
Um,
but those are usually the 3.3 volt battery, 3 volt batteries, and the 1.5 volt batteries, not the battery you want to use for this work.
okay.
You get it.
Yeah,
However, I could still have used that symbol. Let me show you. I think I get what you mean. So I could still use this symbol right over here. I could still do this. Okay. And then when I'm defining the footprint for the battery, I can choose a connector. Okay. But then it will not be ideal because we are not putting the battery on on the PCB. Is that okay? You can use this battery if that battery is supposed to be mounted directly on the PCB, but that's not what we are doing. Do you get it?
okay, so wait, so like even though let's say like it cannot be mounted directly on the PCB, but you can connect it to the terminal port, and then you connect it to the rest of the circuit. Is
Exactly.
that
So
also possible?
what really matters is how I choose its footprint. Okay,
Ah,
exactly. For the symbol, batteries have to be two terminals, right? So far as it has two terminals and I choose the right footprint for it, that's okay, right? But the whole thing is physically the battery that we want to use, we can't mount it on the PCB. Okay, so technically this point is not supposed to be a battery, it's supposed to be a connector for the battery.
Mm.
Okay, so that's why we did this, and we said we wanted to use a DC barrel as our input. Is that okay? That is what mostly we do.
Okay.
Yes, that's nice questions, by the way. All right. So any other questions? Any other questions?
Yeah, okay. So I think that what she was trying to mean was she wants to use the battery symbol and then connect it to the terminals in the schematic.
Use the battery symbol and connect it to the terminals.
Are you seeing that right now? We are imagining that anything we are doing here will be on the PCB. And then anything else will connect. It won't be here. We will have it physically and just put it on the PCB.
Yeah.
But I think she was trying to communicate something like, okay, if that's the notion, then we should put the battery symbol that you had here in our mind, then connect it like how we have done physically
Oh,
to the
okay.
terminals here.
Oh, okay. Yeah, but that wouldn't be ideal, okay? Because the moment you put the battery symbol in there, it will become confusing. The thing is, it's not the battery that you are using, right? It's a connector. Do you get it? So we are just trying to be intuitive here. It's the connector that you are using. So there is no need putting. So like I said, so far as you are designing your system, and you know what you are doing, I mean that's okay, right? But I just want to do the right things right from the beginning. So we want to use a DC barrel as our point of power input, okay? So once that is the point, then we have to use the right component symbols for them. Remember, we said that every component has what? A symbol, okay? And these symbols are unique for the component. Now, unless you are the only one going to be working on your circuit, that's fine. But if you are not, then I mean, you can't use a battery symbol in place of a DC barrel. Okay, so let's say instead, I know I'll be in the physical PCB, I'll be using the DC barrel, but then I use the battery symbol to replace it. Now, fine, you could do that, but that is not a proper thing to do. Okay, if you are the only person who is going to be working with your on that thing, that's okay. But if not, anybody that you give that to, you'll be confusing the person. Okay, so this is a good thing to do. Okay, I don't know if you are okay.
Yeah, I'm good.
Yeah. All right. So any other questions, because we are about to change hands? Okay. This is just supposed to be something that you can practice overnight. Okay. That's why I took a very simple project, so we can finish the PCB. So overnight, while you are learning, you can easily complete both the schematic and the PCB. And we will need it for tomorrow and the rest of the days. Okay. So any other questions? Jifa, Albert, and the rest. Any questions?
Hello.
Yeah.
Okay, so we took a course last semester on drawing schematics,
Okay.
and like what we did, it was basically a design work. So we'd either be given a problem to solve, and we have to design a push button that does this, or we have the schematic to interpret. So can we interpret? So if I'm interpreting what you've done, how am I going to do it?
So okay. So tell me, how do you think you would interpret this? Assuming this was given to you as part of your class.
I'm not
You're
sure.
not sure.
But what I
Okay.
was drawing, what I was drawing is like it's not close to what we did.
Really?
Yes, even if I applied, yes.
Okay, so you know the project we are trying to do, right? So the garage lamp project, okay? So the lamp, we have a garage lamp that we want to power with a 12-volt battery. Is that okay? And we are designing a circuit for a circuit to deliver 9 volts out of the 12 volts for the garage lamp. Is that okay? Basically, that's what we are doing. So first of all, we need, since that battery is big and we can mount on the PCB, we need a place for to connect that battery, the energy from the battery. Okay, so that's what we are doing with this component. This component is basically a connector. We call it DC barrel. Okay, that is this connector here. Okay, call it DC barrel, a DC barrel. And this is one of the connectors that we mostly use for power connections. Okay, if you have seen an Arduino has one of these things on it. Okay, that's where we attach the external voltages to. In case you want to power Arduino to do the barrel, okay, Arduino has one of these. So once the power comes in, we are calling that, we are identifying that power that has come in as our battery. Is that okay? So basically we are telling KiCAD that this pin is a power source and we want to call it battery. Okay, so this power flag that we have defined here, that is the job it is doing. It is telling KiCAD to treat this pin as our power input. Is that okay? Then once the power comes in, we want a means to be able to switch it off, so that anytime we want to switch it on or off, we don't have to go and remove the terminal from the battery, but we can just simply press the switch on the PCB. Okay, so the power comes in, we connect the positive side of the battery to pin 2 of this particular switch, so that we can switch it between these 2 points. So when we switch it between 2 and 1, it means it will be off. When we switch it between 2 and 3, then it means it will provide 12 volts for the rest of the circuit. Okay, so once the 12 volt gets here, the next thing we do with it is now route it through a resistor, and we calculated this resistance in the previous session. Okay, then again, the bulb that we are going to use, I'm anticipating that it is not something we can put on our PCB, right? And even if we can put it on our PCB, remember we are trying to light up a garage. So chances are that we would want the bulb to be hung somewhere on the ceiling. Is that okay? So if we put the bulb on on the PCB, that means anytime we want to switch it on, we will have to probably put a ladder there to reach the ceiling. So it's not something that we want to do. So rather, we would like to connect a connector on the PCB, and using copper wires, we would rather extend the connection to the bulb. So that means that we can conveniently put this PCB somewhere nicely, connect its wire, a long wire as we need to the battery, and also connect a long wire as we need to the bulb. Is that okay? Then this particular PCB can be somewhere that we can easily have access to in order to switch it on or switch it off. Okay, so basically that is what we've done. Okay, what we did in that circuit is what we are trying to build the PCB for. Okay, yeah, I don't know if you are okay.
Yes, please, I'm okay.
All right. Okay, so remember the KiCAD.
Please wait.
Go ahead.
Please, could you go over the power SRC?
Power SRC. Where is that?
Yeah.
Oh, okay. Yes, the flags. Okay, so every circuit requires a power input. Is that okay? And unfortunately for us, if we had used a battery, like something like this battery symbol that we have here, let me bring it up. So this battery symbol, okay. So look at the description here. Battery voltage source. Is that okay? So KiCAD already knows that this is a voltage source. However, in this particular situation, our voltage source is coming from somewhere, But KiCAD requires that there has to be something that is serving as the source of voltage for this circuit. Is that okay? So the way you do that is by defining. You see, in programming, we will call this we will probably call this global declaration, right? We are declaring ahead of time that, hey, Mr. KiCAD, we will be using these power sources. One will call the battery, one is the 12 volt, and one is ground, right? So anywhere we put any of these flags, treat it as a power source. Is that okay? Treat this as what? A power source. So when KiCAD sees this symbol on anything, it knows that this is a ground power source. When it sees 12 volts, it will know that this is a 12 volt power source. When it sees battery, it will know that this is a battery power source, so that it will not complain to us that you didn't connect a power source in your work. Okay, these things are for the purpose of the electrical rule checker. Okay, so I don't know if you get it, but it is
Yeah, I
advisable.
guess it.
Yes, it's advisable to do this, to tell KiCAD that your power source is coming from somewhere. Okay, so it should just focus on where you put these flags. Once you put this flag, you should treat that thing as what? A power source. Is that okay?
Thank you.
All right. So if we click on this and try to open the, you realize that uh, so you can see that the reference is PWR, which means power, right? So KiCAD knows that this is a power input. Okay. All right. Please, any other question?
Yeah, hello.
Yeah.
Please. You see there was a part where you clicked on one of the buttons and that round thing came, and it was like it was selecting wherever there was 12
Yes. So
volts. It
that
made
is
it click.
the highlight wires and pins.
That
This second
um.
button.
So what's the essence of highlighting? Is it for KiCAD to know something or for
No, no,
me
no. It's
myself?
just for me to know where what is connected to, right? So as I highlight the ground, I know that the ground is connected to
Um.
these things, right? It's just to show you where a particular signal connects to. Sometimes, if your circuit is very big or large, these things can be
Um.
difficult to trace, right? So once you
Okay.
highlight that signal, any other place that it connects to will be highlighted.
Okay. Understood.
Yes. So if I
Understood.
want to trace where all the 12 volts connects to, then I can select it and you can see that now all 12 volts are what? Highlighted, even
Highlight.
including the flag. Okay, so it's just
Mm,
for tracing signals.
okay.
Yes. I like the questions. Please keep them coming. Any other question? Any other question? Any other question? All right. So I'll end the question and answers here. We'll get into another phase of this work.